This is the third part of a series of class notes on polynomial functions. And let's continue looking at in behavior, and in particular let's look at the in behavior of some particular functions. So it'll say describe in behavior of, and first let's look at g of x is equal to 5x to the 7th plus 3x squared minus 10. And the first step is to find the leading term. And the leading term here is going to be 5x to the 7th. And then you're going to identify the leading coefficient. And the degree. And in this case, the leading coefficient, what we also call a to the n, is equal to 5. And the key is whether that's positive or negative, and that's positive. And then we're going to identify the degree, which we call n, and n here is going to be 7. And the key question there, is it even or odd? So remember that. The leading coefficient, you wonder if it's going to be positive or negative. The degree, whether it's even or odd. So this is positive and odd. And then what you want to do is you want to apply your rules. And our rules were the leading coefficient test, or the leading term test it's often called. And in this case we have positive leading coefficient, odd degree. That means that we're in this case, this choice here, an is positive, the leading coefficient is positive, and the degree is odd, so it looks a lot like x cubed. So then we're going to describe the in behavior. And oftentimes I just draw a little sketch to start with. And in this case it looks like x cubed, so it looks like this, and I don't really know what happens in between. I'm kind of done. All I need to do now is I need to figure out how to say it. And one way to say it is you can just fill out this. As x goes to blank, y goes to blank. And as x goes to blank, y goes to blank. First we're going to look at it as x goes to positive infinity, and then as it goes to minus infinity. As x goes to positive infinity, then if you notice, y goes to positive infinity. And as x goes to negative infinity, y goes to negative infinity. Now we're going to do exactly the same thing, but we're going to just use a different notation, and we're going to use what's called the limit notation. And limit notation is simply this. You're simply going to fill in these gaps. You start off with limit as x goes to minus infinity of, in this case, g of x, and the limit as x goes to positive infinity of g of x. And this is just a simple way of writing the same thing that we did before. This says as x gets closer and closer and closer to minus infinity, does g of x tend towards something? And if we notice our graph, it does. In fact, if you look at our graph, as x goes to negative infinity, y goes to negative infinity. So this is just minus infinity. And then here, as x goes to positive infinity, what happens to g of x? X goes to positive infinity, g of x or y goes to positive infinity. And that's all you do. This is a more informal way of doing it. And this was just a more formal way of doing it. Other than that, it has exactly the same meaning. Let's look at another example. Let's describe the in behavior. Let's look at f of x is equal to minus 4 x to the 6th plus 3x to the 3rd plus 2x minus 1. So again, the first step, leading term. The leading term, minus 4x to the 6th. Second, identify the leading coefficient. And in particular, is the leading coefficient positive or negative? Leading coefficient is a to the n, and that's equal to -4, and that's negative. So a to the n is less than 0. And then find the degree. Now the degree, you don't want to find out if it's positive or negative, you want to find out if it's even or odd. In this case, the degree is the highest power, so in this case, n is 6, so that's even. So the degree is even. Then what we look at is we look at our rules. If an is positive and the degree is even, it looks something like this. It looks a lot like n y equals negative x squared. So the end behavior, in fact, that's the way you might want to think about it. The end behavior is like y is equal to negative x squared. And if you want to draw that, it looks something like that. So what we're saying is we don't know what happens in the middle, but that's what happens in the end. If we want to write it informally, we simply go as x goes to negative infinity, y goes to blank, and as x goes to positive infinity, y goes to blank, and we fill in these blanks. So as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to negative infinity. If we write that in limit notation, we go limit as x goes to positive infinity of f of x, and the limit as x goes to minus infinity of f of x. Normally you wouldn't say positive infinity, you'd say infinity, but just to be careful, sometimes I do that. As x goes to positive infinity, it gets closer and closer to negative infinity. The limit of fx as x goes to negative infinity is it also goes to negative infinity. And that's how you do in behavior.